What if our universe is only one of many? The multiverse is the hypothetical set of all universes, everything that exists. Together they include space, time, matter, energy, information, and every possible set of physical laws. Scientists and writers call them parallel universes, alternate universes, many worlds, different names for overlapping ideas. A common metaphor is a patchwork quilt of separate universes, each with its own patch of reality. In the next 9 minutes we'll trace the history, the search for evidence, classification schemes, and the debates that follow. Let's begin with how the idea developed over time. Ideas of countless worlds go back to ancient thinkers. Some credit pre-Socratic philosophers and the atomists like Leucippus and Democritus. Epicurus and Lucretius suggested many worlds in their atomist philosophies. During the Renaissance, Giordano Bruno spoke of infinite worlds, an idea both poetic and dangerous in his time. The term multiverse itself appears in late 19th century thought, and the debate moved into physics by the 20th century. Statistical physics and quantum mechanics introduced ideas of many possible histories. Schrödinger even joked that multiple histories really happen simultaneously. Through the 20th century, cosmology, inflation theory, and quantum interpretations expanded the discussion. From textbooks to TV and movies, the multiverse captured the public imagination in recent decades. But scientists debate whether multiverse ideas are science, philosophy, or both, because direct testing can be difficult. Next, what if any evidence could point to other universes? Scientists have searched the cosmic microwave background, the afterglow of the Big Bang, for signatures of collisions or imprints from other universes. Initial claims using WMAP data suggested possible collisions, but higher-resolution Planck data found no statistically significant evidence. Some analyses have spotted puzzling signals, for example unexpected spectral features after the Big Bang era, but these remain debated, and often may be noise. One speculative idea is that matter from another universe might have been injected into ours, a dramatic claim that needs extremely high evidence standards. There are strong observational limits. Many proposed universes lie beyond our cosmological horizon and may be forever unreachable. Because of that, critics argue multiverse claims often lack falsifiability, a core pillar of scientific testing. Yet many respected theorists support multiverse frameworks, others remain skeptical. The debate is active and ongoing. To bring clarity, theorists devised classification schemes. Let's look at two influential ones. Max Tegmark proposed 4 hierarchical levels of multiverses. We'll show each in turn. Level 1, an extension of our universe. Infinite space with Hubble volumes that repeat, so identical regions occur far away. Level 2, eternal inflation creates bubble universes with different physical constants. Different laws can emerge in different bubbles. Level 3, the many worlds interpretation of quantum mechanics. Every quantum outcome corresponds to a branching world. Level 4, the ultimate ensemble. Every mathematically possible universe exists as a structure. Brian Greene describes 9 ways universes might be arranged. We'll show each type briefly. Quilted, in infinite space, all configurations repeat somewhere beyond our horizon. Inflationary, pockets formed during inflation produce distinct universes. Brane, our universe sits on a membrane in higher dimensions, other branes host other universes. Cyclic, colliding branes create repeated big bangs, cycles of birth and rebirth. Landscape, string theory's many vacuum solutions make a landscape of possible laws. Quantum, branching at every quantum choice, the many worlds picture. Holographic, information encoded on surfaces can describe full volumes, hinting at parallel encodings. Simulated, universes run on advanced computers, or created by civilizations with toe-level tech. Ultimate, contains every mathematically possible universe, an extreme form of Tegmark's level 4. Other models include twin worlds or mirror universes that could explain matter-antimatter asymmetry. Black hole cosmology even suggests our universe could be the interior of a black hole in a larger cosmos. The anthropic principle says, if many universes exist with different laws, we necessarily find ourselves in one compatible with life. Out of a vast ensemble, only some combinations of constants permit stars, chemistry, and life, which may explain apparent fine-tuning. Critics invoke Occam's razor. Is postulating infinite unseen universes more complex than other explanations? Proponents counter with algorithmic simplicity arguments. Tegmark argues ensembles can be simpler, others like Paul Davies warn about theological-like leaps. Both views are part of the debate. Prominent proponents include Tegmark, Greene, Guth, Linde, Susskind, and many others. Skeptics include Hossenfelder, Ellis, Penrose and others who stress testability and empirical rigor. The discussion sits at the border of physics, philosophy, and metaphysics, and that boundary is itself important to explore. Whether each possibility is real or merely hypothetical affects how we think about probability, identity, and causality. If simulations or mathematical realities underlie physics, even the nature of existence becomes a question for both scientists and philosophers. For now, much rests on theory and indirect inference. New data, clever tests, or conceptual breakthroughs could shift the argument. Scientists continue to look for subtle imprints in the cosmic background, gravitational signals, and quantum experiments. Whether the multiverse exists or not, contemplating it expands our view of reality and the limits of scientific inquiry. If you enjoyed this tour of possible worlds, subscribe for more deep dives. Comment your favorite multiverse idea below. Credits and sources listed in the description.